Hello, well, this is Math 114, 4.3, linear equation, solving linear equations by addition or elimination method. However you want to call it, it's the same thing. So, objective 1, solving linear system by addition method. Again, same thing. Before we start, let's recall. For the addition method to work, so remember, there are different types of linear equations or lines. The ones we know are ax plus by is equal to c, which is known as standard form. The other one would be y minus y1 equals mx minus x1, which is point slope. And finally, the famous y equals mx plus b, which is slope-intercept. For this method to work, our equations must be in standard form. So, let's start with our problem as it is. Are both our equations in standard form? No, they're not. So we have to manipulate this a little bit. So I have 4x equals negative 2y plus 4. I'm going to add 2y to both sides. Now we have 4x plus 2y is equal to 4. This is in standard form. Now I'm going to get this one. And I have negative y equals negative 3x plus 3. I'm going to add 3x to both sides. Now I have 3x minus y is equal to 3. So now they're both in standard form. Let's add another sheet. Dotted. Because we're going to run out of space really fast. Let's copy this. And take it to the next page. So we're literally going to put them to add each other, or as the name states, addition method. We're going to add each other. The other name of this is elimination method. So the idea of this is to add them to get to eliminate one of the variables. So let's have 4x plus 2y is equal to 4, and 3x minus y is equal to 3. We're going to be adding downward. So which one would be the easiest one to eliminate? In this occasion, it's the y. Why is it the easiest one? Because one's already positive and the other y is already negative. So that means they're subtracting. We're just missing the bottom equation is missing a 2. Correct? So therefore, the only thing we're going to be doing now is, let's multiply the bottom by 2. So we have 4x plus 2y is equal to 4. And I have 3x minus y is equal to 3. And we said we're going to multiply by 2. So I'm going to distribute. So I have 4x plus 2y is equal to 4. 6x minus 2y is equal to 6. So let's add down. So I'm going to go 4 plus 6 is 10x. 2y minus 2y is equal to 0y. And 4 plus 6 is 10 again. This becomes 10x is equal to 10. Divide by 10. So I have that x is equal to 1. Okay. So now that I have my x, my first variable, I'm going to use that one to solve for y. And again, the easiest one would be the 3x minus y because the y is almost by itself. So I have 3, but I know what the value of x is. That's going to be 1 minus y is equal to 3. So I have 3 minus y is equal to 3. Minus 3 to both sides. So now I have negative y is equal to 0. Divide by negative 1. So I have that y is equal to 0. So the solution for this equations or system of equation is 1 comma 0. Okay, so for example 2, we have 3x minus y is equal to 27 and 4x plus y is equal to 8. Well, you can notice that the y's are already canceling each other out, and also that the equations are both in standard form, so they were really polite to us this time, and we can start by immediately adding to eliminate one of the variables. So 3 plus 4 is 7x. Negative y plus y is 0y. And 27 plus 8 is 35. This leaves me with 7x is equal to 35, so I just need to divide this time. So x is equal 35 divided by 7 is a 5, so I have my first variable. After that, plug it into one of them too so that I can get a answer for that one. I really don't care which one. So I personally would choose the second equation because the y is already positive. So I just need to plug in and subtract. But again, that is up to you. So we're going to put in 4. But I already know the value of x, which is 5. Plus y is equal to 8. 4 times 5 is 20. Plus y is equal to 8. And 20, or 8 minus 20, because we're subtracting this time, will give me y is equal to negative 12. So my answer for this one is 5 comma negative 12. Now, on this one, they were a little bit harder on us. They weren't as polite. Why? Because on this one, it's not in standard form, so we need to manipulate both of the equations. So I have 2x is equal to 9 plus 3y. I'm going to subtract 3y to both sides. So I have 2x minus 3y is equal to 9. Then I have 4y is equal to 8 minus 3x. I'm going to add 3x to both sides. And I have 3x plus 4y is equal to 8. Now, if you notice on all the previous problems, I'm always putting the x first and then the y. X first and then the y. X first and then the y. That is not a rule. That is just a habit I have. Y, alphabetical order, x comes before the y. So it's just a habit that we have in math. But either, I don't care which one you put first. 2 plus 3 is still the same thing as 3 plus 2, so we'll get the same solutions. Okay? However, if you're going to be doing this through a calculator, which you can, a graphing calculator to be exact, x must always be first, which is the top variable. You'll see what I'm later on when I start doing this by the calculator, you'll see what I mean. So now I have 2x minus 3y is equal to 9. And I have 3x plus 4y is equal to 8. Again, I'm going to eliminate the y's because one's already positive and the other one's already negative. However, we do not have a simple negative y and a plus y. So we need to do some manipulation. This is where the LCD comes in, or since it's not denominator, it's the LCM, which is the least common multiple. So to find the LCM, I have that 3, and 3 is only 3. However, 4 is 2 times 2. They don't have any numbers in common, so I'm just going to write everything down. 2 times 2 times 3, which is 12. So the number in common is going to be 12. So that means that on top, I'm going to multiply by 4. And the bottom equation, I'm going to multiply by 3 and distribute. So this means that I have 8x minus 12y is equal to 36. Distribute. So I have 9x plus 12y is equal to 24. We're going to do the addition. So this becomes 8 plus 9 is 17x. Plus 0y is equal to 36 plus 24 is 60. So this becomes, well, let's add another page. Let's copy from here. Whoops. There we go. So therefore I have 17x is equal to 60. Divide by 17 on both sides. So I have that x is equal to 60 over 17. So let's continue. Now that we have an x, we must find y. And we have two options. We have 2x minus 3y is equal to 9, and 3x plus 4y is equal to 8. I don't care which one you use. I'm going to use the bottom one again because y is already positive. So I have 3x plus 4y is equal to 8, which was one of our initial equations. Then I have 3 times, but I already know the value of x, which is 60 over 17 plus 4y is equal to 8. 3 times 60 is 180 over 17 plus 4y is equal to 8 minus 180 over 17 minus 180 over 17 to both sides. This cancels that. Then I have 4y is equal to 8 minus 180 over 17. We must have the same denominator, so this is over 1. So now I have 4y is equal to 8 over 1 minus 187 over 17. So I must multiply by 17 to both sides. So 8 times 17. So I have 136 minus 180 over 17. So 136 minus 180. That's going to give me 4y is equal to negative 44 over 17. Now I'm going to divide everything by 4 to leave y by itself. So I have y is equal to negative 44 over 17. Remember that you divide fractions by using the reciprocal and then multiplying. So that means that 4 becomes 1 over 4, which we can simplify into 4 times 11 over 17 times 1 over 4. The 4's cancel out. So my final solution for y is negative 11 over 17. Therefore, the solution for this problem is 60 over 17 and negative 11 over 17. Use the objective 2, use the addition method to identify systems with no solution or infinitely many solutions. Okay. So, oh, look, they were kind enough to already give us something we can work with. So we have x plus 2y is equal to 4, and 3x plus 6y is equal to 13. Now I'm going to manipulate the top one by negative 3. Distribute. Why? Because I'm going to be eliminating the x. So I have negative 3x minus 6y is equal to negative 12. And we have 3x plus 6y is equal to 13. So this becomes 0x plus 0y is equal to 1, which is 0 equals 1. And remember with the theorems we had before, since the statement is false, then we have no solution. So let's do the next one. So I'm going to do, again, it's already in standard form. They were kind enough to start us with that. So I have x minus 5y is equal to 7. And 3x minus 15y is equal to 21. Again, I'm going to use the top one to multiply. So I'm going to multiply everything by -3 and distribute on this one. Then I have -3x plus 15y is equal to -21. Then I have 3x minus 15y equals 21. And look at that. 0 equals 0. Since my statement is true with no variables, then we have infinite many solutions.